Question number 1 grows at a linear rate. So the table's pretty helpful. If you organize your data in a table, the X and the Y. Okay, the X is going to be the size number, and the Y is going to be the number of cubes it takes to build that size. So size 2 requires 1, 2, 3, 4, 5 cubes. Size 3 requires 1, 2, 3, 4, 5, 6, 8 cubes. Size 4 is 11. Size 5 is 14. Size 6 is 17. Size 7 is 20. It's linear because each size requires 3 additional cubes. So every time you go up a size, you go up 3 cubes. You go up 2 sizes, you go up 6 cubes. So it's growing at a pretty predictable constant rate. Now, size 1 would require only 2 cubes, and size 0 would require -1 cube. So B, if we do B first, the function that describes this rate of growth is, because it's linear, it is y equals mx plus b. We need to find two things. We need to find the m, the change, the slope, and b is the starting point. B is always the mate of 0. B happens at the very beginning. The beginning is 0, always 0. So b is a -1, m is slope, which is rise over run, and that would be 3/1. This y is my rise and x is my run. So these are going up 3 while these are going up 1. Whoa, don't know what I did there. So the answer for B is the function is this. Let's see, the number of cubes is equal to this formula right here. You take 3 and you times it by the size, and then since we started off at a -1, let's take 1 away because we started off in the hole, so let's take it away. So if you want to find the 80th size, you're going to take 80 and you are going to times it by 3. That means they added 3 cubes 80 times, and then you got a -1 because we started off -1. So the answer is 239. 80 times 3 is 240. 240 minus 1 is 239. The domain. Okay, the domain is every element here. The domain is a list of numbers. In our picture, if you look at the picture, the first element is 2, and then 3, and then 4, but you cannot include anything in between 2 and 3. There's no 2.5, no 2.75, nothing in between 2 and 3. Only whole number amounts, 2, 3, 4, so on and so forth, all the way to size infinity. The range, that's always your y's, it's your outputs. Okay, the range is similar. The range is a list of numbers. The first in our range would be 5, and then 8, and then 11, and so forth. So the number 6 would never show up on our range. The number 7, we're not going to build something with 7 cubes. We've got to have cubes 5, 8, 11, then add 3, add 3, add 3. Okay. Next, figure out which family it comes from and give me the function. I wonder. Okay. So let's figure out how it's changing. This guy right here, from 8 to 2, that was a decrease. That went down 6. From 2 to a -4, that went down 6. 4 to -10. Okay. This one's going to be linear. So A is linear. And since it's linear, it is y equals mx plus b. B is at the beginning. B is 2. And m is, this is my rise, and this is my run. And this is kind of a trick question because these are going up by 2's. up by 2's, and I need to know it's going down 6 every other time. I need to know how much is it changing every single time. So my slope is going to be rise over run, and it is going to be a -3. So your function is y equals a minus 3x plus 2. The middle one, I need a calculator. Okay, the middle one, 56 to 14, that shrunk. 42 times, 14 to 0, that went down 14 times, but now look, 0 to 14, it's going to turn around and go up. That's up 14, 14 to 56, that's up 42. So it's definitely not linear. If it's exponential, that means these would be doubling or tripling or quadrupling, so I bet it's going to be quadratic. So if I find the difference between a -42 and 14, that is a positive 28, that is a positive 28, that is a positive 28. Because my second change is constant, it's quadratic. So this is quadratic, and on IXL, all you had to do was, they gave you this. They wanted you to find the A. That's it. There's more. There's a B, and there's a C, but all you had to do was find the A, which is a good start. And the A is related to this. So if this was an acceleration problem, 28 would be your acceleration, but we need to take the average, so it is going to be 14. So you always take your second change and divide it by 2. 28 divided by 2, because that's going to give you an average rate of speed, and that's what you use. C looks like from here to here it's tripling, there to there, triple, triple. So this is going to be exponential. IXL, the exponential, they wanted you to find A times B to the X. B we just found. B is your rate of growth. So we've got y equals A was the beginning. So this is A, -1 is your beginning, times 3 to the X. That is your function. Number 3. Okay. Alright. Too many of you guys are still doing this. You're doing square root 4 plus square root 5 equals square root 9. That is no. Remember this, if you have 3 square root 2, this number is your coefficient, and this is your unit. So coefficient tells you how many you have. If you have 3 of these square roots of 2, that looks like this: square root of 2, square root of 2, square root of 2. You can only combine like units. You can only add square roots of 2 to other square roots of 2. So you have a -1 square root of 54, and you got 3 square roots of 6. This is the unit, this is the unit. This -1 is how many you got. And you got -3 square roots of these 45. So square roots of 45 are totally different than square roots of 6, which are totally different than square roots of 54. But 6 is done. 45 is a big number. 45 has squares in it. 45 is 9 times 5. 45, there is your square right there. Square root of 9, that's a perfect square. So from 45, you need to take the square out. That is the same thing as a -3 times the square root of 3 squared times 5. That's 9 times 5. This square root is going to undo that square. So that kills the square. So the square root is going to start on the 5. 3 comes out. And since there's a -3 out there, you times them. -3 times 3, that is a -9 square roots of 5. Okay, my middle was done. It was 3 square roots of 6. And the first one, 54, or 9 again. Okay, 9, that's my square. 9 is 3 squared. So I'm going to take the 3 out. I'm going to leave the 6 in. So it's going to become a negative 3 square roots of 6. Okay, now here's what you got. Now, this unit and this unit are like units, so they play together. And if I've got negative 3 and a positive 3, that is nothing. You've got 0. So your answer is you should have negative 9 square roots of 5. Okay, number 4 is a multiplication problem. So this one's totally different. Multiply, you multiply everything on the outside. 7 times a minus 7, that is a minus 49. And you times everything on the inside. Okay, so it's 15 times 6 times j. Now if I have j3 times j8, that is equal to j3 plus 8. You add the exponents. When you're timesing letters, you add the exponents. So that's j11, and that would be k4. Okay, now 15 is made of a 3 and a 5, and 6 is made of a 3 and a 2. So there is my square. So here's what I've got. I got negative 49. Square root, I've got 3 squared times 5 times 2 times j to the 11 times k to the 4. Okay, so this square root is going to kill that square right there. So 3 comes out. So it should be a negative 49 times 3, which is a negative 147. On the inside, my 5 and my 2 turn to a 10. Okay, now, if I've got 11 j's, the question is, how many squares are there? Because every square is going to be undone by a square root. So if I've got 11 j's, that is j squared 5 times and 1 j left over. So if I have j squared 5 times, that's j to the 10, and this is my j to the 11. So this square root is going to kill 5 of these squares. So that means 5 of the j's come out, and this leftover guy stays in. K to the 4, that is 2 squares. 2 squares is a power of 4. So this square root kills that square, kills that square. So on the outside, I've got k squared. And on the inside, all I have is a 10 and a j. And that's it. Number 5. Okay, you can never leave in the denominator a radical. Ever, ever, ever. So you're going to multiply this by 1. Because you can times anything by 1 and not change its value. Now the bottom, you have 2 1s. So that's a 1 and a 1. And then you got 2 squared root of 6. So that's a square root of 6, square root of 6. So if you've got all these ingredients here, you got a 1 and a 1 and a square root of 6 and a square root of 6. You've got 2 different units. I'm measuring in 1s and I'm measuring in square roots of 6. So because those are 2 different units, you cannot add them together. And the only way to undo a radical when you have 2 different units is you've got to multiply it by its conjugate. So you've got to times this by 2 minus 2 square roots of 6 times the top by 2 minus 2 square roots of 6, and here is what happens. Something awesome happens. Times the top. 8 times 2. 8 1s times 2 1s is 16 1s. 8 1s times negative 2 square roots of 6 is negative 16 square roots of 6. Okay, on the bottom, if you do the lot of distributive, 2 1s times 2 1s, that's 4. 2 times the negative 2 square root of 6 is negative 4 square root of 6. And then 2 square roots of 6 times 2 is a plus 4 square roots of 6. And 2 square roots of 6 times the negative 2 square roots of 6 is a negative 4 square roots of 36. So I times the outsides. I times 2 and 2. 2 and a negative 2, that's my negative 4. And times the underneath. 6 times 6 is 36. Okay, this is what happens. These will zero out. Negative 4 square roots of 6 plus 4 square roots is that's 0. So on the bottom, you got 4. Square root of 36 is 6, so you got a negative 4 times 6, which is 4 minus 24, which is on the bottom, you should have a minus 20. And on top, we got 16 minus 16 square roots of 6. Okay, now you cannot leave this. You're dividing both. Here's what you got on top. You got 16 ones, and you got 16 negative square roots of 6. So that's the square root of 6 negative, square root of 6 negative, square root of 6. You got 16 of these, and then you got 16 ones. You're dividing both of them by a negative 20. A negative 20 will simplify with that, and it will simplify with that. So let's simplify them. 16 20ths, divide those both by 4. You need to change it to a 4, a minus 4, and a 5. So 16 20ths is really 4/5. Divide those, simplify this fraction. Change them, divide them by 4. Oh, whoops, we gotta do 6. Okay, 6. Simplify this fraction. Those play together since they're on the outside, so that will change to a 2, and that will change to a 1. Simplify this fraction. 5/15. Always, always, always simplify first before you start playing around. 5/15 changes to 1/3. And if you've got x cubed on top, you got a cube on bottom, and you got a 4th power on bottom, or a cube on top, 4th power on bottom, this cube is going to undo 3 of these. So the cube is going to kill 3 of these, so on bottom you just got x. And that's a cool number because that's just 1. So on top you've got 2, on bottom you got square root 3x. Now I only have 1 of these, which is nice. I can't leave a radical on the bottom, so this I'm going to times by 1. I'm going to times it by itself. I'm going to times by square root 3x times the top by square root 3x. Well, I'm not sure what I'm doing. Okay, now the top, the 2 times is the 1 and leaves me 2 square roots 3x. On bottom, the 1 times is the 1, and that's just the 1, and the 3x times is the 3x, and that creates 3x squared. And the square root is going to kill the square. So on top I got 2 square roots of 3x. On bottom you have 3x. 7. Okay, 16 feet per second. There we go. That's how fast objects increase. So what will its instantaneous speed be at 6 seconds? It will be 6 times 16. What was that, 96? That is 96 feet per second. Okay, what will the distance? Now remember, distance equals rate times time. What will be the distance that thing travels between the 6th and the 9th second? Okay, so the 6th second is going 96. The 9th second it's going 9 times 16. 9 times 16 is 144. Okay, so distance equals rate times time. So the rate I'm going to use is tricky because the rate was changing. He started off going 96, but then every millisecond that goes on, he's falling faster and faster. He's increasing speed. So he starts at 96, he ends at 144. I'm going to use the average speed right in the middle. Since he was increasing at a constant rate, I can use the average speed. So the average is going to be 144 plus 96 divided by 2. 144 plus 96 divided by 2. Whoa. 144 plus 96. Divide that by 2. Okay, for the speed, I'm going to use 120. And for the time, it took him 3 seconds to change from 6 to 9. So 120 times 3, the total distance only between the 6th and the 9th second was 120 times 3, so 360. That thing traveled 360 feet from time 6 seconds to 9 seconds. Okay, now what will the total distance be from 9 to 0? So 0, 0, 9, what did we say 9 was? 9 times 16, 144. So 0 to 9, that changed 9, so distance equals rate times time. For time, I'm going to use 9. The rate, 0 to 1, 0 was the slowest, 144 is the fastest, so I'm going to use the average of those two, which is 72. 72 for the speed. Since the speed was changing, you got to use something right in the middle of the slowest and the fastest. So 72 times that by 9, that is 648 seconds. Okay, let's skip D for a second. Let's go to E. Write a model for the distance the rock has fallen. The distance equals rate times time. So the distance equals the rate. What you do is you take the time and times it by 16, and then you have to average it with 0. So then that's going to give you your fastest speed. Then let's find the middle of that in 0. So you're really going to plus the speed at 0, which is 0, and you're going to divide that by 2, and that is my rate. And the time is time. So it is the distance equals 8 seconds squared. 8 times time squared. The position is going to be, if you start him off at 1,500 feet, you're going to take that total 1,500 and you're going to subtract the distance that object goes. And so you can type this in on your calculator, look at a table. That rock is going to hit the surface somewhere between 13 and 14 seconds. Okay, number 8. You need to take this exponent of 2 and take it to everything. Take it to the negative, take it to the 2, take it to the x, take it to the y, take it to this radical. So you have this, you got a negative 2 squared, so that's a negative 2 times a negative 2. You gotta have 2's gotta go to the negative, so I gotta have 2 of the negatives, 2 of the 2's. That's positive 4. If you take it to the x, it already has an exponent, so that's going to be x to the 3 times 2. If you distribute an exponent to something that's already got one, you times them, so that's x6. Take it to the y, the exponent of y is 1, so it's going to be y1 times 2, it's going to be that. And if you take it to this radical, a square root and a square, they undo, so it's going to be 5x5. And since this is all times, 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 4 times 5 is 20, x6 times x5 is x6 plus 5, and y squared. Number 9 is a multiplication problem. And square roots of none of these are like terms, so I cannot add square roots of 10 to square roots of 6. So here we go. I'm going to have square root of 10 times square root of 30. That is 10 times 30. 10 is, check this out, in 30, that is 10 times 3. There is my square. So square root of 10 times square root of 30 is 10 square roots of 3. And if I do square root of 10 times a minus square root of 18, that's going to be, so in front of here I got 1. 1 times a negative 1 is going to be a negative 1, square root of something. So let's see what we've got. If we've got a 10 and an 18, I'm not sure, 10 and an 18, let's bust them up. 18 is 9 and 2, and 9 is 3 and 3, and 10 is 2 and 5, so check it out. I'm going to take a 3 out, and I'm going to take a 2 out, and I'm going to leave a 5 in. So if I take a 3 out and a 2 out, you times them. So instead of, it's going to be a minus 1 times 3 times 2, so it's a minus 6. Now let's do 6 times 30, and that is going to be nice 6 times 30 because 30 has a 6 in it. So there's my square. So I'm going to take a 6 out and leave a 5 in. So that's going to be a plus 6 square roots of 5, and these two are 0. Negative 6 square roots of 5 plus 6 square roots of 5, that's nothing. So now let's do the last times the last. A negative 1 times 1 is going to be a negative 1. And 6 and 18, that's awesome because 18 has a 6 and a 3. So I'm going to take that 6 out. So it's negative 1 times 6, so that's negative 6. And I leave the 3 in, and square roots of 3 and square roots of 3 are like units, so these play together. So if I've got 10 of them, and I got 6 negatives, a negative and a positive cancel out, so 10 minus 6, you got 4 of the square roots of 3. So that mess cleaned up to be just 1 unit, the square root of 3, and you got 4 of them. Good problem. Number 10. Okay, let's simplify the top first. So this u and this u. On top I got 2, and I've got u cubed, and I've got v minus 2. Okay, on bottom I gotta take this 4 to everything. It's gonna be 2 to the 4th. U already has one, so times them. Minus 4. V has one, so times them. V8. Okay, now the rule is no negatives. So I'm taking these to the bottom where they will turn positive, taking these to the top where they will turn positive. So I've got on top 2u cubed. And on bottom, okay, 2 to the 4th is 2 times 2 times 2 times 2 is 16. I'm taking these u's up where they will become positive. I got V8 and I brought down V2. Okay, 2/16, that will simplify to 1/8. And let's see, I've got U to the 7 and V to the 10. And that is as simplified as it gets. Number 11. Okay, anything to the 0 is 1, so you can kill that. Distribute this, take it to everything. So I'm going to have y squared times 2 squared times x to the 6 times y to the minus 2. Okay, I got to make it a fraction. Well, actually, look, if I've got these y's and these y's, you add the exponents, so it's y2 plus negative 2, so it's y0, which is just 1, so kill your y's. And 2 squared is 4, so 4x to the 6th. That is 11. 12, a rectangle. Okay, it is 2 square roots of 6 and 3 square roots of 5 long, and it's 3 square roots of 6 minus 4 square roots of 5 wide. So this side is also 3 square roots of 6 minus 4 square roots of 5, and this side is 2 square roots of 6 add 3 square roots of 5. So A, find the perimeter. That's this piece plus you add all the way around. So I'm going to start right here. So it's 3 square roots of 6 minus 4 square roots of 5. Add this piece right here on top. 2 square roots of 6 plus 3 square roots of 5. Add this piece on the side. 3 square roots of 6 minus 4 square roots of 5. Add this piece on the bottom. Plus 2 square roots of 6 plus 3 square roots of 5. Okay. Now, let's add up all your square roots of 6. This guy, this guy, this guy, this guy. So I got 3 of them. 4, 5, 6, 7, 8. I've got 10 of the square roots of 6. Now let's add up all the square roots of 5. Minus 4 plus 3. Minus 4 plus 3. So minus 4 is minus 8. And 3 plus 3 is 6. So it's a minus 2. Square roots of 5. And square roots of 5 and square roots of 6 are totally different units. You cannot add them. That is your perimeter. Okay, the area. The area is length times width. So your area, take this guy, 2 square roots of 6 plus 3 square roots of 5, and you're going to times it to this guy, 3 square roots of 6 minus 4 square roots of, and we just did one of these, so I'm not going to work this one out because we just did it right here. So it's just a lot of distributive times this to this, times this to this, then times this to this, and this to this. Oh, okay, good. 13. Now, here we go. Here is a lesson. Don't ever forget it. There's a number line. Okay, the real numbers. The real numbers, there's 0. The real numbers are any number on this line. This line, I mean, there's a number right here, this one. But in between 0 and 1, there's all sorts of funky numbers. There's all sorts of 1/2, 1/4, 1/3, 1/7, 2/7, 6/7, 6.5 sevenths. I mean, there's some crazy numbers. So the real numbers, any number that can go on a number line, this number line right here is a real number. Now, the real numbers are divided into 2 groups. So the reals, here we go. There are those that are rational, and there are those that are irrational. So there's 2 types, rational and irrational. Okay, now, here's the history. Rational. The very first set of numbers was called the natural numbers. And these are 1, 2, 3, 4. But then, as time went on, man discovered, you know what? There's a cool number we're leaving out, and that is 0. 0. 1, 2, 3. So, they decided to include 0. You can have nothing. And then they got smarter and smarter and said, hey, well, if you can include nothing, what about negatives? So integers. Integers are the negatives. -2, -1, and the wholes, and the naturals. So, the integers include everything below them. They include the wholes, they include the naturals. The wholes include everything below them, only the naturals. They do not include everything above them. Okay, and then above the integers, someone said, hey man, there are numbers in between these numbers. So let's not forget about, there does exist in real life 1/2. So the rationals, there exists 3/4. The rationals include everything below it. They include the naturals, the wholes, the integers. So the rationals are inclusive of everything below. The rationals are fractions. Okay? Now, some of these fractions, there's 2 types of fractions. Well, there's 3 types of fractions. Fractions like 1/2, that's called terminating. If you approximate it to a decimal, it is 0.5. So it's it's halfway between 0 and 1, 0.5. There is fractions like 1/3, which is 0.333 forever. And these are called repeating. So these 2 types are cool. If they repeat, that's sweet. We know what it is. 1/3, we can find it. Terminating, that's pretty easy. Now, irrational are numbers that we really have a hard time trying to explain. They are numbers if you try to change them to a decimal. So if you try, so we deal with this, 1/2 is a perfect exact quantity. If you try to approximate it to a decimal equivalent, anytime you try and change something to a decimal, That's bad idea. So if you try to change these to decimals, they are not terminating and they are not repeating. So if you try to approximate square root of 2, it doesn't end, but it does not repeat. So definition of irrational is non-terminating, non-repeating decimals. Decimal approximations, I guess. Decimal approximations. So if I try to change it to decimal, it's 1.4142135. I'm just going to go on forever. They're chaotic. Most of them are square roots. Square root of 3, square root of 5, square root of 7, square root of 8. Square root of 9 is awesome. Square root of 9 is over here. Square root of 9 is the natural number. Square root of 9 is 3. Square root of 16 is 4. So there's your two types of numbers. Now, when you add the sum of two rational numbers can result in an irrational. That is impossible. If you add a rational number with another rational number, your answer, 1/2 and 3/4, that is going to be 1 1/2. Nope, 1/2 and 3/4 is 1 1/4. 1 1/4. Your fractions are always going to create other fractions that either terminate or repeat. That is the same with subtraction. This is impossible. So you're trying to breed numbers, crossbreed numbers. So two rationals, the product, that's multiplication. Okay, if you have, these are all impossible. Impossible, impossible, impossible. Okay, if you times two of these rational numbers, since multiplication is just repeated addition, and addition will always, if you take the funkiest number, it will always result in a fraction that either terminates or repeats with the pattern. And since multiplication is repeated addition, impossible, impossible. Division, same. Okay, so now the sum of two irrational numbers. Now we're only looking at the irrational side. So if you take two of these and add them, can you create a number over here? And the answer is yes. You can take a negative square root of 3 and you can add it to a positive square root of 3, and that will equal 0. And 0 is a pretty sweet rational number. First showed up in the whole numbers. It's in the integers and it's in the rationals. The difference, can you subtract? Yes, I can. I can take this crappy, I can take pi and I can subtract pi and I'm at 0, which is a whole number, an integer, and a rational. So we just call it a rational number. The product of two irrationals, you can take square root of 2 and times it by square root of 2. This is a non-terminating decimal. This is a non-terminating decimal, but it creates square root of 4, which is 2. The quotient of two irrationals. Can you divide two irrationals and create a rational? Yes. Square root of 27 divided by square root of 3 equals square root of 9, which is 3. So add and subtract. I mean, 0 is kind of a, try to hit 0, try to create 0. You can create 0 with addition and subtraction by opposites. And multiplication times it by itself, it always creates a perfect square. Okay, last one, the bonus. You are an idiot for taking option 1. Option 2, like on day 28, you will make more money than your whole month, the sum combined from option 1. Option 2, if it starts off slow, don't let that fool you. It's going to grow and it's going to get huge. So what is the function for option 1? It's linear. So the money you're going to make is going to be this. What is it going to be? It's going to be $400 an hour plus 10 grand. Option 2. Okay, your money, you start with this. So look, goofballs, from my Excel, you should have had this. Day 1, you make a penny. Day 2, you make 2 pennies. Day 3, you make 4 pennies. Day 4, you make 8 pennies. Go back one. Because we need, if it's exponential, you need this. Y equals A times B to the X. B, we know what B is. B is times 2, times 2, times 2. So we got 2. Should be Y. Well, not Y. I guess it's Y is money. The money you're going to make is equal to something 2 to the X. And 0.005. That is 0. 0.005 times 2 to the X. Now look. 0.005 times 2 to the X on day, oh, my calculator's not going to show that many digits. Yeah, day 24, day 24 alone, he's gonna pay you 83 grand, almost 84 grand. Day 22, he's gonna pay you 42 grand. So if you add those two together, that's 120 grand. Day 25, he's gonna pay you 167